Okay, number 7, we have tangent squared y plus x to the third equals negative sine y. So we can do tangent y and then secant squared y and then dy over dx, right? Quotient rule, not quotient rule, chain rule. And then plus 3x squared equals negative cosine y dy dx. Let's try to combine the dy dx's together. So we can do 2 tangent y secant squared y, right? And then plus cosine y. And that whole thing dy dx factored equals negative 3x squared, right? Okay. dy over dx then equals 2 negative 3x squared all over 2 tangent y secant squared y plus cosine y. Right? And then number 8, 2x, right, plus 3y squared dy dx equals 4x third minus 1 dy dx. Oops. 3y squared plus 1 dy dx equals 4x squared minus 2x. dy over dx equals 4x to the third minus 2x all over 3y squared plus 1. Okay, number 9, we have secant squared, right? And then x squared and then 2x, right? Chain rule minus, or actually plus, right? Plus sign xy, and then we have to do product rule. So y plus x dy dx. Okay, and that's equal to 2xy plus x squared dy dx. Okay, so we're going to combine all the dy dx's again. So let's see, I think for that to happen we need to send this over here and then we have to distribute some things. So okay, y times sine xy plus x times dy dx sine xy. Okay, and then I'm gonna do minus x squared dy dx equals 2xy and then minus secant squared x squared. Okay, 2x, right? 2x secant. Okay, and then we can just do x sine xy minus x squared dy over dx equals 2xy minus 2x secant squared x squared. Yeah, and then minus y sine xy dy over dx is equal to 2xy minus 2x secant squared x squared minus y sine xy all over x sine xy is x squared. Okay, so this will be our answer. Number 10. Okay, number 10, I think we can try to do product rule again, okay, because quotient rule might be way too complicated. So let's just do product rule. So C cosecant y times e to the negative x equals xy to the third. So cosecant y would definitely be negative cosecant y, cotangent y, and then dy over dx, right? And then e to the negative x. And then we have to do product rule. So this will be negative e to the negative x times cosecant y equals y third plus 3y second dy dx times x, right? Okay, so negative cosecant y cotangent y e to the negative x, and then minus 3xy squared, this whole thing, and then dy dx factored out is equal to y to the third power plus e to the negative x cosecant y. Oh no. And then so dy over dx is basically equal to y to the third plus e to the negative x cosecant y all over negative cosecant y cotangent y e to negative x minus 3xy squared. Okay, and then moving on to number 11, x to the third minus e to the y equals x to the second minus tangent y. So 3x to the second negative e to the y, and then dy by dx equals 2x minus secant squared y. Move everything, dy by dx, right? And then negative e to the y, and then positive secant squared y is equal, dy dx is equal to 2x and then minus 3x squared, right? dy over dx then equals 2x minus 3x squared all over secant squared y minus e to the y. Okay, and then 12, 2y dy over dx minus y third plus 3x y second. Yeah, you have to keep track of everything. So 2y, okay, then minus 3xy squared, right? And then plus 1 over y, and then dy by dx is equal to 1, right? 1, and then plus y to the third power. Yep, okay, that's how you do it. And dy over dx is equal to 1 plus y to the third all over 2y minus 3xy squared plus 1 over y. I think we'll just leave the 1 over y like that. Or if you really want to, you can put that as negative 1 power. Yeah, maybe ask your teachers about what their standard is for this one. I think for this situation, it probably is fine because implicit differentiation itself is pretty complicated. Since we made some mistakes, let's just try to check back to see if we did things right. So, and y to the third plus x, okay, y to the third plus 3xy second dy dx. Okay, and then 1 minus 1, okay, got it. Alright, I think we're good. Yeah, we're good. Yeah. Let's go to number 13. So 2x y second plus 2x squared y, right? Yeah, and then dy over dx is equal to 2x minus 6, right? Okay. So 2x squared y dy over dx is equal to 2x minus 6 all over 2xy squared. Nope, that is not right. Oopsies. Minus 2xy squared, right? Okay. And then dy over dx would essentially be 2x minus 6 minus 2xy second and then 2x squared y. So implicit differentiation, especially when it becomes like more complicated, like a lot more terms, right? It's gonna get a little bit more complex. So you have to make sure that you're keeping track of all your answers, and each term you're doing the right operation. Like for example, if you're having like a product rule thing, that you have to make sure that you're having proper product rule form, and then you also have to make sure that you're doing dy over dx for the y term differentiations. Yeah, so it's a little bit complicated, but once you get the practice, it becomes easier. Yeah, and a good thing about implicit differentiation is that you don't have to simplify a lot of the things. You can just leave it pretty complicated as it is. Yeah, and that's excused. So implicit differentiation is convenient in that way. Okay, almost last question. 2 sine x and then cosine x plus 2 sine y cosine y, and then don't forget dy dx equals negative sine and then xy times y plus x dy dx. right? Okay, and then let's do 2 sine y cosine y dy dx, right? And then we're going to try to distribute this out. So negative y sine xy, and then negative x sine, or negative x dx, right? Negative x dy over dx sine xy, right? So let's just try to put this part on the other side, right? Sine xy, and this is equal to negative y sine xy and this to the other side, which means negative 2 sine x cosine x. Okay, and then dy over dx is times 2 sine y cosine y plus x sine xy equals negative. Okay, I'm just gonna copy this part. Okay, and then dy over dx is equal to, let's do this one more time. Oops. Well, basically it's equal to, okay. Yeah, it's just equal to this part over this, or I'll just write it out. All over 2 sine y cosine y plus x sine xy. Yep, this will be our answer.